Okay, we are live. Okay. Hello, everyone. Thank you for joining us. This is the third episode of the GDSC-UI workshop series. And today we'll be having Mekuleyi take us on the cloud foundations for Google. So if you are watching this video live on YouTube and you have any questions, you can drop it in the chat feature below. Yes, thank you for joining us. You can also introduce yourself in the comment section. Yeah, so first I would read the citation of our facilitator. Hold on. Okay, Mekuleyi work as a developer and technical product manager. His interests are TensorFlow, Google Cloud, and Flutter. Anthony resides. Okay. Thank you so much, Michael, for taking out time to facilitate this series today.
Hello, yeah. Hi, Victoria. Thank you for having me.
Yes, we can continue.
Oh, okay. Yeah, my name is Michael. We'll be going through like Google Cloud Fundamentals 01 today. Yeah, you can basically find me on Twitter at Monarin. Victoria has said a lot about myself. I'm a technical product manager. I'm also a developer, a software engineer, and basically that is what I do. So we'll be discussing like cloud fundamentals. We'll be taking O1. O1 is basically like understanding that you probably have a lot of workload to like do on the cloud, or you probably have a couple of things that you want to move from either like your local environment to cloud environment, or probably you already on a cloud environment. You just want to like move to maybe Google Cloud, and basically that is what we are considering this talk on. And so yeah, so we'll be starting with like what is Google Cloud Computing, managing Google Cloud Platform Services, like the Google Cloud environment. We'll also be discussing like the Google Cloud environment, infrastructure offerings or GCP, like compute storage, big data, AI. Also be discussing like networking services on GCP. We'll also be diving deep into like compute services and like DevOps services and then GCP projects. So it is like spawning across all the offerings that GCP offers you, irrespective of whether like you are fresh or whether like you just like basically joined. So if you're moving like from one cloud provider to like another, if you're moving into GCP, it will like be like a big help. But if you have not even moved to the cloud, if you are doing running it on local servers, this is also for you. So it's going to be quite technical. I'm going to be, because there's a lot to cover, I'm going to be breaking most of those points down into what we'll be referring to as just quick points. So we'll be covering like the whole lot of GCP, starting from like console. We'll be going down to features. We'll be going down to We'll be going down to the platform services, we'll be going down to features, going down to a whole lot of stuff. So we'll start with the GCP console. GCP console is like a general console that we use to like access Google products. Everybody knows that Google Cloud is very user friendly. We also have like configuring the GCP CLI. The CLI tool is like the tool that I use to access a lot of GCP products using using commands on a basic command line to command line interface. That's what CLI means. You could also access like a GCP environment, like using the Cloud Shell. When we say using the Cloud Shell, there's a shell, there's an environment where you can bring in files, you can copy files, you can download files, and then you can also just try to use GCP. And then you have accessing GCP using GSUtil. GSUtil is a tool that is available like on the terminal. You can use it to like log in into GCP. You can use it to provision servers. You can use it to do compute. It's just really outside like your Google Cloud environment. So if you're like using GSUtil, like you're probably on your local computer, you're probably on your laptop, and then you can provision your keys, and then you can connect to like your cloud environment. Yeah, and basically also configuring the cloud SDK on your local computer using GSUtil and other like tools. So that is how basically you manage Google Cloud Services. This is really, really like the methods. A, you use the console. B, you configure the CLI still on Google Cloud. Use the Cloud Shell, that's a specialized cloud environment. You can also use G Cloud. You can use GSUtil on your local computer. um you can also like configure your cloud SDK. Yeah, that's basically it. And so we'll quickly discuss like the networking arm of GCP, because like you need the way you have like local networks where you connect wires to computers, to your database, to your processing, to your compute, is also the way we do in like GCP. We are just like connecting most of them via APIs and via clicks. And so you have your virtual cloud network. Your virtual cloud network will probably comprise of everything in your cloud network, your connections, your VPN, your VPC, your virtual private cloud, your virtual private network, your proxy parameters, then your gateways, the endpoints you'll be accessing, your main network, and then your subnetwork, your DNS, your domain name service, the routers you'll be using to connect, and firewalls, also your cloud router and your security. So GCP can handle everything for you, and then you just need basic knowledge. But a lot of people like to provision their own things bit by bit. So just we can actually take off the load of a lot of this specific knowledge from you. That's what GCP wants to do. But then if you say, okay, you want to go on, you want to do your own like configuration, you want to work on your own configuration, you want to work on your own configuration. Give me a second. You want to work on your own configuration, you want to make everything custom, and then GCP will just like, okay, we'll give you all you need. You have access to the virtual cloud network, you have access to the VPN, the proxy, the gateway, basically everything you need. So yeah, the network arm is there for you. We also have identity management. This is very, very key because you want to protect the resources that you have on GCP, like your organizational resources. You want to ensure that those organizational resources are well protected. You want to understand identity access management. Identity access management is basically who has access to what, and who is controlling what, and who is controlling what, and who has access to like what. So you want to create roles, you want to understand the organization, you want to create members, you want to create service accounts. Service accounts are basically accounts that have access to specific services, and you want to be able to just give those keys, those pen files, distribute them around people that need access to what. Sometimes you want to create a custom role. Might want to create a custom role that has like a broad amount of services, probably API services like BigQuery and some other services. And yeah, that identity access management is like very, very key in GCP. So you can also do identity access management like via an API. Like you can provision an API that you would use to give people like access to specific resources on GCP. So you also have your KMS system, you have your data security system, you have your auditing system, and there's roughly a strong penetration testing unit also on like GCP to just like help um, ensure that a lot of the things that are in your servers are like very, very secure. The people that are getting access to like your resources, they are very, very protected, and nobody can break in and just have access to like all your resources. So GCP also like helps to like protect all the identity management, and GCP does it like with, so people do not have to give like your password or your admin password around or share it around. No, you can just provision identity access management. You can give your developer tools. You can give your DBA access to the DB and access to like tools on the DB, and then you just like provision resources in accordance to like people that like need those resources. So like this is always my favorite part of like GCP, because the idea of like the Google Cloud is to take most of like to take most of the network, to take most of like the Google Cloud compute and just transfer it to the cloud. So you are setting up like a private network at home or a private network in the office. You want to ensure that you can take in like your workload. There's no crash, there's no downtime, and then GCP just does that for you. So and I've done this really many times because I've created many virtual machines, I've created many virtual instances, I've run like very sophisticated workloads, and so you can easily spin off like a VM quickly in a minute. Sorry. So a VN in itself is like a computer on its own that has like an operating system, most likely Ubuntu or Linux. You can like install packages on your VM. You can provision like storage services on your VM. So what I do is at a point in time I was using a VM and I connected my VM to a cloud storage bucket. I also connected my VM to a GitHub repo. So I was feeding data off like a GitHub repo, processing it in my VM, running things in the background while I would log out and maybe do something else. And then I was taking all the data um to my cloud storage network, to my cloud storage, yes, to my Google Cloud Storage. So you will see cloud storage. Google Compute enables you to like take in the power of like a compute of a processor and just provision it in the cloud. So another beautiful thing is you can provision large servers like 16 gig RAM servers. You can provision 4 of them. You can scale it vertically and you can also scale it horizontally. Scaling vertically means just adding more powerful VM instances. Scaling horizontally means adding the same sort of VM instances, but just more. So if you scale vertically, you maybe move from like 8 gig RAM to like 16 gig RAM. If you scale horizontally, it just means that you add another 8 gig RAM. So also there's persistent disk. So you can have like a persistent disk, HDD, or solid state drive, where you can connect your virtual machines to like a solid state drive, and then all the data from like your virtual machines could like be going to your solid state drive, and it's just like perfect and beautiful. And you can also do a lot of load balancing. What's load balancing? Load balancing is basically distributing requests evenly between virtual machines or machines like on the cloud. So if I have 10 requests coming into my network and I have 5 machines, I do not want 9 to go to one machine and then 1 to go to one machine, and then I don't want the 3 other machines to have nothing to do. So you probably want to split all your requests into like all the machines evenly with like low latency. So the idea is that you want to just ensure that you are splitting all your requests into like enough pipelines, and then you're just making sure that everything is going like cohesively. So it's not just that requests are like all over the pipelines, and then you probably will not be able to give me a second. You probably will not be able to um balance your network. So also normal compute engine actions, like I'm heavy on compute engine, so I can spend like an entire day discussing compute engine. Compute engine actions like running a workload, especially like data processing workload, running a batch of data, processing information about things that you want to do. and stuff like that. And then you have Google Cloud Storage. I'm also very, very big on cloud storage, especially like code line cloud storage. That's basically storage that you want to keep for a long period of time. So let's say you process data for like over a year and you need to keep that data somewhere. You employ like a code line storage. Name line storage is basically things that you use like very, very often. And then Google Cloud Storage buckets are like there's what we call the GFS, the Google File System, storing a lot of information in like storage. So it's basically like a hard disk of like different nested file systems where you can just import things and keep them. And then you have SQL. The query language like in the cloud, like keeping your SQL and your NoSQL DBs in the cloud. You have Cloud Spanner, you have Cloud Data Store, you also have Cloud Bigtable. There are also pros and cons of like storage. So everybody understands like the three like most important things about keeping data, that they have to be persistent, that they have to be available, and they have to be durable. So like there's a big difference between code line and nearline storage, and those differences are also showing like the pros and cons of like those storage. You also have to understand like the billing aspect of like storage, because if you are keeping and Google is so cheap, like it is in gigabytes, and then you are able to like have like a so the way Google Cloud Storage bills is that per gig you have billed like a particular amount. So per month you can pay something as low as 0.0 something per gig. So you can store like terabytes and terabytes of data and just be paying like $2 per month. And so is a lot for like the amount of data you want to store. There's also like trade-offs. So if you want to store data, you want to do NoSQL or SQL or just use the GFS, the file system, you probably have to understand to like a good aspect what you're trying to store and like the what you need it for. So if you will be regularly taking that data, I will not advise you to store it in like Google Cloud Storage, because it's going to be difficult accessing and reaccessing data from like cloud storage system. If you have like a group of files that you want to store and you want to lock in and you want to be able to access it through an API, it's most likely very, very much better to keep it in a DB. Even like when you're keeping it in a DB, you also have to decide if you want to have fast reads or faster writes. And then you have to now differentiate if you want to keep it in an SQL DB or in a new SQL DB, and the way you want to structure a DB. So there are a lot of trade-off efforts in like storage options. There's also the multi-cloud environment. Multi-cloud environment basically means that um, you have like a lot of cloud environments. You have a lot of cloud environments and you're connecting them. A lot of people do hybrid environments. So you have a local environment and you have an online environment, and you're connecting your local environment to your online environment. Some people do like environments between like the three major cloud providers among GCP and AWS. So yeah, that's what about cloud environment. So for the DevOps guys, containers on Google Cloud. Usually when you build projects on one machine, you want those projects to be available on that machine, and you don't want to have to stress about either if somebody changes their machine, the project will not work. So you use containers, you containerize your application. Then we have the Kubernetes engine on Google Cloud. We have like the container registry, there's Kubernetes load balancing. So balancing like your Kubernetes containers. You have choosing like your Kubernetes engine and app engine, and containers on compute engine. So like I said, like if you don't have like specific knowledge on a lot of these things, Google Cloud just extracts all that for you and then just allows you just do a click, and then Google Cloud will provision those things and they'll take care of those things for you. Yeah. And then we have big data processing. I'm a big fan of this because I've used it a lot. You have data flow for your data pre-processing. You have stream and batch processing. So what's the big difference between stream and batch processing? So stream processing is processing like a continuous stream of data, a continuous flow of data that is flowing in like a stream, or data that is flowing effortlessly. Sorry, batch processing basically means like taking in the data in batches, in cohorts, processing everything. We also have Apache Beam SDK. Apache is basically for providing extremely large amounts of data. We have like monitoring your data through Stackdriver, data transformation, like I've said, cloud data flow. So you want to be able to do a lot of processes between taking your raw data and then bringing out information through an API. So data flow allows you to do all those processes bit by bit and in bulk. So like you have like 4 terabytes of data coming into your first process, and you have like 4 terabytes of data going out of your process. So what data flow allows you to do is to have like a custom processing pipeline where you can provision things, you can provision servers, you can like build what you want to build. And then there's Dataproc, also a good tool. Then you can create data clusters that process data, and you can manage those clusters. Now, Google Cloud allows you, Google Cloud has a service that can automatically create a cluster, scale down your cluster, and turn off clusters when they are not available. So it can be auto-managed, or it can also be managed manually. That's like the definition of automation of jobs. That also like depends on like what you're going to do. So I believe that we've gone through like the major services that are available in Google Cloud, especially like for this Cloud Foundations one. We discussed IAM policies, IAM, identity access management. We also like discuss data processing policies. We also discuss like the compute engine. We discuss like containerization. We discuss big data processing. We discuss like storage. And like for a foundations class, I think this is enough to say this is probably a very, very good start, like Google Cloud Foundations. So what you probably would need is a deep dive on like each of the topics that we have mentioned. So you need a deep dive on each of those topics. And the best place to do that deep dive is Coursera. Like Coursera has courses on compute, has courses on each of them, and you can just do your deep dive there and just learn as much as you want to. That was where I learned, and that I'm advising you to learn there. So, like, thank you very much. I think we have come to the end of the presentation. Okay, there's also DevOps. It's not possible to like the DevOps guy is out. You can set up continuous integration and continuous delivery. You can set up your Jenkins or your container engine. You can deploy the application on Jenkins. You can create your deployment pipeline on Jenkins. You can create and deploy a cluster. You can deploy your development and your production and your staging environment. You can do analysis and also troubleshooting. Everything all on GCP. So GCP offers you, like I said, you can move all those workloads from like your local machine or like your local storage into the cloud, and then you're just like able to build what you want to build. So questions and answers, and we've come to like the end of the presentation. Well, I don't know if Victoria is here, but that's basically it. So I think you can ask your questions in like the comment section, and we'll probably just pick like 5 questions or 6 questions, and then we'll look at answering them, and we'll see where we go from there.
Victoria, are you there?
Yeah, I think, yeah, Victoria, hi.
Yeah, I'm back.
Yeah, so I was saying we have come to the end of the presentation, and we can just take any questions that we have. Yeah, that's basically it. So,
Okay, thank you so much for that, Michael. So if anybody has any questions, you can drop it in the chat section below. So for people that just want to venture into cloud, what are the things that they have to do? Like, is there a guideline for them to follow?
okay. If you want to venture cloud, you must actually start from like a base profession. So are you a web developer? If you're a web developer, you can like use a lot of the compute service. You can deep dive into like building web apps, deploying web apps, doing your domain service and your subdomain service on the cloud. Also, like, are you a data scientist? You can do big data on the cloud. Are you a DevOps guy? You can bring your workloads to the cloud. Are you like a database guy? You can come and do all your big DB things on the cloud. So it usually depends on, first of all, having like, so the cloud is an extension of what you normally can do by yourself. So it's just like putting a lot of things in scale. So the cloud is an extension of what you can do as a web developer, it's an extension of what you can do as a data scientist, it's an extension of what you can do as an app developer, it's an extension of what you can do as a back-end engineer. So if you want to probably start with cloud, have like a base career, like then extend it with like cloud services. So whatever you just want to do, just extend. Usually when people just want to hop on the cloud and do only cloud alone, they probably just go into DevOps because like all your tooling or most of your tooling is on the cloud.
Okay, thank you for that. I think we have another question in the comment section.
Yeah, so Firestore, like on Firebase, and Google Cloud Storage or Google Cloud Database, they are like, it's very close. And funny enough, if you did like an introduction to Google Cloud, you will realize that Google Cloud is divided into like two. So we have like Google Cloud Platform, which is the Google Cloud or Google.com, and then you have like G Suite. So G Suite is like Gmail and all that kind of stuff. So Firebase is sort of a real-time storage where you can store a lot. Firestore on Firebase is like a real-time storage where you can store things, you can store database, you can store like information depending on how you want to use Firestore. You can choose to expose like Firestore like via an API and then choose to like do awesome stuff. Google Cloud Storage, or should I say, if you're talking about Google Cloud Storage, I'm assuming you're talking about Google Cloud Storage Bucket. So Google Cloud Storage Bucket is more like a file system, like on your laptop, like on your Windows laptop, like how you keep files. It's just like keeping files. Like if you want to keep a video, if you want to keep a movie, if you want to keep a book, that's like you can use Google Cloud Storage. It's basically your file system, moving like all your files from your local machine to like the cloud, and then you pay per gig. So that is like cloud storage. And when you're talking about, okay, so now you're extending the question to like database. So the basic idea of a database is like basic CRUD, create, read, update, delete. Databases now in the context of database will be the same anywhere. It's just that Google now manages like your the compute behind your database and like your database operations. So if now you're saying what's the difference between Firestore and like any other database, it still depends on like your use case of like Firestore and then databases. But like the clear difference of Firestore and GCS, Google Cloud Storage buckets, is that Google Cloud Storage bucket is like for like GFS, the file system. You can keep books, you can keep documents, you can keep videos, you can keep like music in the cloud storage system. While usually Firestore is like for data, processing data, passing data around, just like a makeshift DB, if I answered your question.
Okay, I guess that answers his question. So if anybody has any question, please drop it in the chat section below if you're on YouTube. Okay, Michael, do you have any last words or word of advice for people that are watching?
Well, if you want to come into cloud, like I said, Coursera is the place for you. You can like do a lot of cloud and things on Coursera. You can learn the cloud on Coursera. You can extend your capabilities in whatever you do in data science, on the web, in DevOps, in backend via the cloud. So like go on to Coursera, search for a course. You should probably apply for financial aid unless you have a bucket of cash to spare. And then feel free to like jump on the cloud and like do cloud things. Yeah, it's really exciting.
Okay, thank you. Thank you everyone for joining. this session. We'll have our last workshop series next week, Saturday. No, upper next week, Saturday. That's March 5th. The upcoming workshop series will be on Firebase, so you don't want to miss that. Click on the subscribe button on your screen so you can get updates on our upcoming series. Yeah. And if you want to get access to this video on YouTube, just copy the link. You can always come back to watch it, right? It's available on YouTube. Thank you everyone for joining the call. Bye. Don't forget to like and subscribe to the GDSC-UI channel. Bye everyone. Michael, do you want to share your social media handles for people that want to reach out to you or something? Okay, that's good. Okay.